The main aim of iSense is to build a new generation of digital sensing systems to detect infectious diseases much earlier than we currently can. Our aim is to build new tools to help support public health efforts in the UK and internationally.
The work that I do focuses on the development of nanomaterials. So these principally are nanoparticles, and the way that we sort of create these nanoparticles, the way we design them so that they can perform additional functions in diagnostic technology. One of the great things about being part of a hugely collaborative network like iSense is the number of different disciplines and expertise that all come together to make iSense. The aim here is to achieve a more decentralized model of disease testing. We want to realize a healthcare system where testing can be done at a more personal bedside level, whether that's within GPs, whether that's within hospitals. We want to move away from having to send samples off to centralized facilities, and we want to move to a point where you can tell someone their result at their bedside or at their home.
I'm a postdoc at UCL, and I'm involved in the development of an app designed to assist self-testing for HIV in the context of KwaZulu-Natal. We need a lot of different images of HIV tests for the model to be accurate, and as eventually the model will be used in the field, the pictures that we use to train the model have to be representative of field conditions, which is why we're asking our field workers to help us by collecting images of HIV tests as part of their daily routine.
But the ability of mobile phones to help map outbreaks is also really important, using geospatial information to identify disease hotspots and help support interventions. So the iSense data dashboards were first used in a partnership with the Africa Health Research Institute and one of the largest treatment as prevention trials for HIV, which involved over 24,000 participants in KwaZulu-Natal. The dashboards allowed us a unique ability to link different data sets and to help inform the rollout of the trial and more widely to support patient management in South Africa. Our work on iSense flu detector is really exciting, and it harnesses online symptoms reported for syndromic surveillance.
So we're exploring how symptoms reported by users on Twitter or web searches can be used as earlier indicators of the outbreaks of infectious diseases. We've got a number of partners that we're collaborating with. Some are providing us with data. So for example, we get search query data from Google via something called Google Health Trends. We get Twitter data from, of course, Twitter. And we get data from the Royal College of General Practitioners, which we use to help train our machine learning models. In addition, we work very closely with Public Health England, who are responsible for influenza surveillance in England.
iSense has developed a lot of really exciting technologies. We want to see these being uptaken by industry. We want to see generally them creating an impact in the world. So we want to be collaborating with industry. We want to be collaborating more broadly with academia. We want to interface with healthcare systems to try and take the technologies that we've developed in the lab here, evaluate it in the field, and make sure that they can actually go into a commercially successful output.